Example, E equals x, knowing that x belongs to n star and x is less than 12. Here we have two conditions that the elements of E belongs to a non-zero natural number and the elements should be less than 12. Because we have less than, so 12 is not included in the elements. If we had less than or equal, it means that 12 is included in the elements, okay? So here 0 is not an element and 12 is not an element of the set E. So the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The second set, A equal x such that x belongs to E. So the element of A belongs to the set E, okay? And the element x is a prime number. Prime number is a natural number which can only be divided by 1 and the number itself. And we have to pay attention that 1 is not a prime number, okay? So the prime number are 2, 3, 5, 7, 11, 13, 17, etc. So here in the set E, the prime numbers are 2, 3, 5, 7, and 11. B equal x such that x belongs to E. So here the elements of E are also elements of E. The elements of B are also elements of E. And the elements is even. Okay, so the elements of B are even. So here we have two conditions, that the elements of B should be elements of the set E and they should be even. Okay, so we look at the set E. The even numbers are 2, 4, 6, 8, and 10. Note, even numbers are numbers that can be divided by 2 and ended by 0, 2, 4, 6, and 8. Example 4, 66, 22, 40, 38. C equal x, knowing that x belongs to E and x is odd. So the elements of C belongs to E and they are odd. Odd numbers are numbers that cannot be divided by 2 and ended by 1, 3, 5, 7, and 9. For example, 5, 39, 17, 13, 31. So in the set E, the elements that are odd are 1, 3, 5, 7, 9, and 11. Type of sets. We have finite or infinite set, empty set, singleton set, pure set, subset, it means inclusion, and equal sets, and finally the universal set, which is the reference set. Finite and infinite set. A set is finite if the number of its elements can be counted. Example, the set of days of the week. The set of students of a school. A set is infinite if the number of its elements can't be counted. For example, a set containing never-ending elements. For example, the set of whole numbers, set of points of a straight line. The finite number of elements of a finite set E is called the cardinal, of which is denoted by card E. So the number of elements, okay, is called cardinal of this set. For example, if we have a set E equals 1, 7, 9, 11, then E is a finite set. Why it's a finite? Since we can count its element. Here the elements 1, 2, 3, 4. So cardinal of E equals 4. B equals set of letters in the word algebra. So the set B will be equal to A, L, G, E, B, R. Here A is repeated, so we write it one time, okay? Then we count the elements to find the cardinal of B. So here 1, 2, 3, 4, 5, 6. We have 6 elements, so the cardinal of B is equal to 6. Empty set. A set that does not contain elements is called empty set or null or void set. The empty set is represented by phi or empty braces. Example, the set of man whose height is more than 6 meters. List of all the positive divisors of 10 that are divisors of 3 other than 1. Here these two sets don't have any elements, so they are empty sets. Singleton set. A singleton set is a set containing only one element. Example, x knowing that x is a natural number and x is between 2 and 4. So it's equal to 3. Since the elements are natural number and are between 2 and 4, 2 is not included in the set, or is not an element of a set, and 4 is not an element of the set, so the number between 2 and 4 is 3. Pure set. A pure set is a set containing only 2 elements. Example, x knowing that x is a natural number and x is between 2 and 5. The numbers between 2 and 5 are 3 and 4. So here, since we have 2 elements only, so E is a pure set. Subset, inclusion. A set A is a subset of B or part of E when all the elements of A belong to E. So if we have two sets, if we have the elements of the first set, all the elements of the first set belong to the other set, it means that the first set is included in the second set. But it doesn't mean that the second set is included in the first set. So here, if all elements of A belongs to E, it means that A is included in E. But it doesn't mean that E is included in A. Okay? Here E is not included in A. A is included in E. Okay? And is read A is included in E, or A subset E, or A contained in E, or E contains A. A set A is not a subset of E when not all the elements of A belong to E. We write A is not included in E and is read A is not included in E. Okay? Example, E equals 1 to 3 and A equals 1 2. Here all the elements of A belongs to E. So we can say that the set A is included in E, okay? But E is not included in A.